Hey there. So today we are going to learn about RFID lock system. So what exactly is RFID first? So RFID means radio frequency identification lock system. So like this is here the RFID RC522 module which we have on the screen, and let us learn about this. The small board here altogether is called RFID module. So this small board is what reads your card. So first we will start with the right hand side, and we have here is some spiral lines, and all over we have a connection, and this looks like the antenna coil, right? But yes, this is a antenna coil. What it does is, this is the most important part of RFID. So this is what makes this chip, the RFID chip. This will send and receive the radio signals to the card, or the chip or anything which you are using. When you bring the card near to this, the antenna will create the magnetic field and communicates with the card. So thinking how does the card look like? The card will look like this. So this here, the white one is a card, and this here is a the same chip we have, closed it in a plastic module. So when you tap this, or you tap the card on this part of the RFID, then this will read the chip number, and it will communicate with the card and chip. So going back to we have one black chip here, which is IC. So what it does is, this small black square chip here is the brain of this board. So totally, this chip, what it will do is, it will process the signals from the antenna. So when the antenna will send the signal to this board, this will process all those and converts them into a digital data, and send it to the Arduino or Raspberry Pi or ESP, whatever the microcontroller we are using, and the that will be working accordingly. So basically, antenna talks to the chip directly. So this is what is done with these two modules here. So now again, one more important part here is a crystal oscillator here on the top right left of the chip. So this silver oval part, this is a small silver component at the top. Here, this what it does is, it provides a timing. It is like clock signal. It will provide all the clock signal, like it is provide timing and helps the chip work at the correct frequency, right? So without this, communication won't be stable. So if you don't have the correct frequency at the correct timing, then all the communication may mislead, like there might be some glitch. So that is why we will be using this crystal oscillator. So now moving forward to, we have some small chips here, like C1, C2, C3, and like that we have till C10. So what are these? These are these small rectangles with C and numbers are actually a capacitors. These tiny components, they are like, they smooth the voltage. Like when the voltage is rushing all over the circuit, the capacitors will smoothen that and remove noise from the signal. Like when we are using signals, it will be like in a vibration one. So for that, some noise may be created. So these capacitors will remove those noises, and it will um, make that signal the make the signal very clean, like there won't be any noise, something like that. So think of it like a cleaners of electricity. And these resistors here, which starts with R1, R2, R3, R4, like that. So these tiny blocks are resistors. They control the current flow. They protect component from getting damaged. Like when the current flow is too much or too high in the system, then there will be some damage, like there will be a short circuit, right? So these resistors will be protecting um, the device from getting short circuited. So here we have one D1 and yeah, and we have one D1 and some LEDs here. So what this does is, these show the power status. When this D1 lights up, that means the sensor, the RFID system sensor is activated. If it is in an off state, then the system is in off. So here, moving forward to main important parts, here on the left hand side we have some pins. So these are the pins where all the communication is traveled, where all the communication is done to the microcontroller, to the monitor and everything. So in this we have important pins like VCC, GND and SBA or SS and SCK, MOSI, and MISO. So what are these pins are? As we know that VCC is for power pin and GND is for ground. So VCC is where this board will get the power, and GND is where all the negative current is passed out of this system. And SDA and SS pins here are used, SDA and SS. Yeah. So these pins are used for the communication purpose, and the other three pin, that is SCK and MOSI and MISO pin, are for SPI connections. So altogether, this full PCB board here is this full blue board here is a PCB board. So altogether it connects everything using a copper tracks. If you turn it, and if you can see here, we can see the copper tracks here. So this will connect everything with one another, and it will hold all the component in one place. So in a quick way to understand this, so this is antenna which sends a receive or which sends or receive the signal, and this chip in here will process the data. This crystal oscillator here will process all the timing and frequencies. These capacitors and resistors will provide the stability for the system, and these pins are connected to Arduino or any microcontroller which we are using. So in a very simple way to remember is, when the signal comes in, the antenna will read that, will send to the chip, and chip will send to the Arduino. That's it. So this is how this will be working. So where exactly is this used? So this can be used in smart door locking systems, or anywhere where we need to we are using the cards as the attendance purpose, and we can use this in ATM cards also. So this is how RFID lock system will be working. So that's it for now. See you in the next video, future robot builders.